Welcome to today's Explainer. We're going to dive right into a massive, honestly mind-bending repository that is trying to do something that sounds almost impossible. It's attempting to mechanize philosophy and theology using rigid, verifiable computer code. It is a wild journey right to the absolute limits of logic, where deep spiritual concepts crash headfirst into highly computational math. And honestly, it challenges everything we think we know about what software can actually do.
So here's the staggering question this whole project is trying to answer. Can you use rigorous, step-by-step mathematical proofs to define the boundaries of the divine, or the actual edges of the universe? I know, it sounds like a total contradiction, but this framework argues that while we definitely can't compute the infinite, we can absolutely use math to map the exact shape of the void it leaves behind.
Let's just start with the sheer scale of the source material here. This repository contains exactly 228 intricately interconnected files. Think about that for a second. 228 files is a monumental undertaking when we're talking about a single, unified mathematical proof. And we're not talking about text documents full of philosophical musings. These are highly structured code files spanning complex topology, deep number theory, and, well, spiritual mechanics. It's a massive effort bridging disciplines that basically never speak the same language. To give you a sense of this, just listen to some of the file names from the table of contents. You've got this incredible blending of the deeply spiritual, like Alpha Omega God's Kingdom or Beatitudes Topology, sitting right alongside intensely geometric computational files like Bracket Reith Braid and Atiyah Siegel Cobordism Functor. It's a total collision of worlds. As you scan through more of these combinations, it really does feel like an overwhelming forest of concepts. I mean, we're going from black hole braid straight into digital hadron collider and cancer topology. Now, at first glance, I know that might sound like a chaotic word soup, but don't let the names fool you, because there is a remarkably strict, unyielding foundational logic holding this entire universe together.
Part 1. The Rustic Church Doctrine.
Okay, to understand how they're actually proving these concepts, we have to talk about their methodology. They call it the Rustic Church Doctrine. Now, unlike standard programming libraries that rely on massive pre-built toolkits, this project operates on what's called the init-only doctrine. That means it relies strictly on the absolute most basic foundational logic. Zero assumptions, zero custom axioms, and absolutely zero sorry commands. If you're a coder, you know sorry is basically developer speak for, yeah, I give up, let's just skip this proof. Not here. Every single thing must be rigorously proven from scratch.
This rustic church philosophy is entirely self-bootstrapping. It proves theorems in the Lean 4 programming language, using nothing but definitional unfolding and basic structural inductions based entirely on the number 1. It's literally like trying to build a modern skyscraper using nothing but individual grains of sand, flat out refusing to use anyone else's pre-made bricks. It is a grueling, painstaking level of verification. So how on earth do they apply this strictness to theology? Well, by leaning on this rigid coding framework, they are mathematically separating finite compiled agents from the infinite. They are encoding theological commandments like, "Thou shalt have no other gods before me," as unyielding structural type theory. Because of how strictly the code is written, it is computationally impossible for a finite agent to be passed into a function where the infinite, or God, is expected. The code simply will not compile if you confuse the finite with the infinite.
Part 2. Deep Dive Echolocation.
To really get a grasp on how this philosophy executes line by line, we picked one random file to deep dive into. And honestly, it's fascinating. Coming in at just over 11,000 bytes of pure, verified topology, echolocation.lean attempts to map a physical process we all know, echolocation, into a highly abstract mathematical operation across an unknown space.
But before we get into the exact mechanics of that file, we really need to understand a vital term that's used heavily throughout this code. It's called a clinomen. In this system, a clinomen acts as a single fundamental unit of mathematical perturbation. It's specifically defined as either a strictly deterministic +1 lift or a -1 contraction. Basically, if you're going to change this universe by even the smallest imaginable amount, you use a clinomen. It is the absolute baseline unit of structural change.
Part 3. The three-step round trip.
Okay, so how does a computational agent actually measure an unknown topological void using this tiny clinomen? Think of a bat using sonar in a pitch-black cave. The code defines 3 precise steps for an agent to bounce a mathematical signal off an unknown ceiling and measure the void it's sitting in. Those steps are emit, probe, and return. Let's break down the computational mechanics of each one.
First up is the emit step.
This acts just like the bat's initial high-frequency ping. The code applies a strictly deterministic +1 Kleinemann lift to a starting mathematical carrier. Thanks to that rustic church baseline logic we just talked about, the code absolutely guarantees that the score of this carrier increases by exactly 1. We are injecting a known, indisputable quantity of structure right into the dark void.
Next comes the probe step. This is the exact moment the signal hits the wall of the cave. The system takes that new post-emit carrier and classifies it against a candidate ceiling of the manifold. If it hits the boundary, it triggers a computationally verified event the code calls a self-similarity violation. It's essentially the math screaming, "Hey, I hit something." By calculating the exact count required to fix that structural violation, the system quantifies the overshoot. It's literally measuring the precise mathematical distance to the boundary of the unknowable.
Finally, we have the return step. This acts as the actual echo arriving back at the bat's ears. The code applies a -1 Kleinemann contract on the exact same face that was initially lifted. Because of the strict geometric proofs underpinning everything, this perfectly inverts the original ping. It mathematically guarantees a closed round trip. It brings the state exactly back to where it started, while retaining the new knowledge of the distance it just measured.
Part 4. Mathematics as Theology.
So, zooming back out to the grander scale here, what does measuring a mathematical boundary actually mean for the theological goals of this whole project? Well, this single echolocation operation brilliantly illustrates their core philosophy. It gives a finite system a way to map the boundaries of the infinite. It uses rigid, unforgiving mathematics to safely probe the edges of the unknowable. Like the author notes in the source text, the topology is what the framework can know about what the framework cannot know. We can't code God, but we can code the exact boundaries where our finite logic hits a wall.
I really want to draw your attention to this beautifully poetic line buried right inside the austere code of the repository. The trill witnesses the sting. The oscillation witnesses the perturbation. Stillness broken by 1 unit of charge made manifest as rhythm. That perfectly summarizes our entire deep dive today. That returning mathematical echo, the trill, is the undeniable, mathematically verified proof of that initial +1 Kleinemann ping against the massive void.
Which leaves us with a staggering final thought on this wild intersection of code, philosophy, and cosmology. If we can use basic structural inductions to write code that maps the boundaries of the divine, securely measuring that gap between the finite and the infinite, what else in our chaotic, mysterious universe is just waiting to be compiled?